All right, so I guess we'll just get started now as a few more participants have joined in. I'll kick my video off. There we go. All right, first and foremost, I'm Danyon Simmons, a Melbourne-based senior consultant with Morfit Group. I'd just like to thank everyone for taking some time out of their day to join us. I promise you it won't be wasted, as I'm joined today by Stefan Prandl, the CTO of Hyprfire. He's going to give us a bit of insight into network detection and response and the key differences between NDR and other technologies such as EDR and XDR. We also have Paddy and Michael from the Hyprfire team who will be actively monitoring the chat for any questions. So if you do have any along the way, please just shoot those through and we will answer those at the end of the session. Now, to get us started, I'll quickly touch on Morfit Group and our partnership with Hyprfire. So as many of you are aware, in the market today, there are hundreds, if not thousands, of vendors that make up the cybersecurity ecosystem. Many of those have a similar functionality, and there's quite a few that are quite niche. Now, as that service provider, we at Morfit Group have to sort through those vendors, as we can't be partnering with every vendor, right? So we need to make sure that the correct decision is made in who we partner with, as we owe it to our customers to provide the correct solutions, the right solutions, ones that meet everyone's use case. Now, when selecting these vendors, it's critical that these align with our existing security solutions and offerings. So a bit of a holistic approach to the whole MSP offering side of things there. But we also need to make sure that these solutions work as standalone services as well. So it's not often that a customer will use or incorporate our whole suite of solutions. So why we selected Hyprfire to partner up with, we thought it'd be quite pivotal to get into the NDR space, but crucial that we exclude those that don't offer a managed network detection and response kind of platform. So that left us with quite a few. You have those big names, the British company Darktrace, the US one, ExtraHop. But now as our customer base is predominantly Australian, in which majority of our customers are not really large enterprise, it makes sense to partner with a business that's Australian owned and also provides this managed network detection and response service at an affordable price. So keeping that in mind, those were part of the selection criteria, but the key requirements were really being we need a proven enterprise grade solution to partner up with. As a trusted advisor, we can't go disappointing our clients with a solution that doesn't meet those requirements and use cases or just doesn't function as expected. And B, we needed to find an NDR solution that was affordable, as our client size varies from as small as 20 seats through to the thousands. So allowing those with a smaller budget to increase their security stack with NDR was critical to the thought process there. Some of the bonuses we get with Hyprfire as well as the deployment's like quite simple. You can get proven results within a day, whereas a lot of these AI and machine learning NDR offerings can take weeks, if not months, to tune and get them into the production deployment side of things there. And to top it off, the team is great over at Hyprfire. They're an Australian organisation focused on Australian customers. So it was a bit of a no-brainer to Morfit to go down this route. Now, I'll hand it over to Stefan, who's going to give us an introduction to Hyprfire, who they are, how they're disrupting the market, and the differences between NDR, EDR, XDR, and EPP. Stefan, the floor is yours, mate.
Thanks, Dan. Let me just get my slides up real quick. Bam. Alrighty. Does that look right, guys?
Yeah, that looks good.
We can see you, mate.
Perfect. Alrighty. So, yeah, hi. My name's Stefan. I'm CTO of Hyprfire. As Dan said, we're Australia's own third-gen NDR company. As I'm sure you're going to find out during this talk, we do things a little bit differently to some of the bigger, more expensive, beefier overseas boys. We aim to be, and we are, more effective, more accurate, faster, and much, much easier and simpler to run. Now, I'm not here necessarily to just sell you all on the idea of jumping onto the Hyprfire train. I'm here to tell you about what the differences between the different parts of the visibility stack are, specifically EDR, XDR, and NDR. I know that XDR is a bit of an ephemeral, strange beast. It tends to have many possible meanings. So we'll talk about that. We'll talk about, what the differences between that and NDR are, why you want NDR in your stack, and even what you can kind of get out of it. Alrighty. So we're sort of breaking this up into 4 major chunks. The first one sort of talks about the broad sort of high level stuff, why NDR in general. Then I'll talk a bit about how it actually works. We'll talk about deploying it, what you need to think about when you're actually setting up to, deploy something like this, not just ours, like any sort of NDR solution in general, and sort of things you can get out of NDR. Right? This is very, generic. It applies to all the NDR systems in general. So, hopefully this will teach you a little bit about what this very often missed part of the stack actually provides, and why it's necessary, and why you really want it. All right. So, why NDR? Simple question. So in order to do this, we sort of have to talk about visibility in general, right? So visibility is sort of what we're trying to achieve here. And the reason we want visibility of things is because, humans are pretty fallible, right? We make mistakes. We get tricked by emails. We get, click on things we shouldn't, so on and so forth. Like, heck, even I do. And theoretically, I'm, actually good at cybersecurity, so I should know better. We can all get tricked from time to time. We're humans. That's how we work. We trust people implicitly. That's our job, right? That's why we're social animals. It's how we evolved. So the problem is that means that humans are very often the biggest threat. You can convince a human to do something for you as a bad guy, they'll do it. And so training and email filters only get you so far because, again, there are humans behind those too, and they're trying to be smart and get around it. Software itself is built by humans, and we humans engineer flaws into the software, not intentionally. It's just that we're not perfect, so we create those flaws. You might think AI is a good solution for that. Unfortunately, AI is learning from us, and we're flawed, so the AI learns the flaws. This is one of the major problems that they have right now. So categorically, we can't rely on just defending using the humans alone. We need some sort of second, backup, right? Something that'll actually tell us more than just what the humans are doing. We need tools that let us see what happens after someone gets in, where they get in, what they're doing, what they might be trying to do next. We need to know what the computers are doing. Now, there's a problem with visibility, and that is that software is kind of ephemeral, right? It's not real. You can't look under the hood of a computer and see the software at work. You can do with a car, if you're a mechanic, that's nice and simple. But if you're dealing with software, you can't see any of it. And so what we kind of rely on are logs, right? So the idea is that software developers engineer parts of their programs to produce text when they're performing certain actions. And the idea is that, these logs can be collected and then analyzed to identify what's going on in the systems underneath, right? So logs can consist of application logs from applications, from the operating system, from devices themselves, think appliances, think networking equipment, appliances as well. OT devices can also produce logs. The firewall produces logs. EDR produces logs. Basically things are designed to produce logs. And those logs ideally are designed to tell you something about what's going on inside the software so that a skilled engineer or someone that knows what the software sort of does can look at it and identify what's going on. And that gets put into a log collector or analyzer, usually either a SIEM or, if you're more modern, XDR. And then that collects up all those logs and something finds stuff, right? This is the idea, right? It's supposed to have some capabilities, rules, AI, logic, theoretically your SOC team or people that are watching it, and helps you find when bad things are happening based on the information that's contained within the logs. So to do that, we sort of build it out of a couple of different bits and pieces. And the general stack that most people are sort of looking at is the EDR XDR stack, or previously the EDR SIEM stack, and before even that, the antivirus log management stack, right? It's basically been the same thing. We've just been updating what the technology does and sort of what the naming convention is. So EDR, endpoint detection and response, what does it actually do? Realistically, it's antivirus with extra steps, right? It's a smarter version of antivirus. It looks for malware. It looks for things that shouldn't be there. It can look for behaviors of certain applications. So if an application like Notepad or Calculator suddenly spawns a PowerShell prompt, that probably shouldn't happen, and the EDR system can pick up on that. So, it collects logs from systems very often, and sometimes even sends it back to an XDR. It observes the application behavior to some extent, varies from which application you're using for EDR to whatever it is, what it actually can collect. It ideally can find known bad tactics from the logs from the operating system, and what you really want for the EDR is the ability to enforce some level of policy, to stop applications from running, to stop people from performing certain actions. Think the sort of things you can do with, Microsoft Defender for Endpoint, which is an EDR system. Ideally, the idea is to stop malware from running. And this is one of the reasons why attackers have moved to hands-on keyboard attacks, because they know that their tools will get stopped by the EDR, right? So that's basically what an EDR is. Sits on the device, your laptop, your desktop, your server, whatever, and watches what happens on it, creates more logs, and theoretically those get forwarded to a log system. Speaking of log systems, the other part of the EDR XDR stack is the XDR itself. XDR, what does the X stand for? Depending on who you talk to, it can be one of many things. It's not a very strictly controlled definition of appliance, right? Generally speaking, you can sort of think of it as a SIEM with extra steps, right? Generally, the idea is one of the big problems you have with a SIEM or a log management solution is that when you collect logs, you then have to tune the system to understand what those logs mean. And so the XDR generally comes with a bunch of those built in. Usually an XDR is vertically integrated with an EDR, and so it already understands what all the logs from that EDR will be meaning, right? Sometimes the X means that it's integrated with a cloud monitoring system that can read the logs from a cloud environment, think AWS or Azure. Sometimes they don't have either. Sometimes it's just a SIEM with XDR, right? It's really, really difficult if you're shopping around for an XDR to find one that actually does what you need, because anything really that's a log management system with a flashy front end could be considered an XDR at the moment, because it's not really well defined. So it's important that when you're looking at XDRs, you actually try and figure out exactly what functionality comes with the XDR and exactly what you'd have to tune the XDR to do. If you're getting a SIEM, well, it's not going to necessarily be tuned to anything. So the trick is that if you get a SIEM and you've got a real crack SIEM engineer or XDR engineer, they can tune the SIEM to be just as good as your average out-of-the-box XDR, and something very often quite a bit better, and it might not cost you as much. So, it's like, can you do anything with an XDR that you can't with a SIEM? And with a couple of tools, probably not, but it can be easier to deploy an XDR simply because it's got more bells and whistles attached. In long story short, EDR does antivirus with extra steps. XDR does log management with extra steps and looks for events. And between the two of them, theoretically, you'll find stuff that's going on computers that shouldn't be going on. There's a problem with this. We're trusting the logs. And as I said right at the beginning, humans are fallible and have problems. Logs actually aren't first-party information. They are reports on things happening that the applications voluntarily create. So they're optional. They're not actually required to be done. So logs can either generate a ton of data that's not particularly useful, or they can generate not enough data and not actually log the things that you want them to log. So developers in general are rarely thinking security first. So they're just kind of producing logs where it makes sense for them in a debug sense to make logs, which can basically mean that you're catching things in a security sense just by the fact that those logs happen to line up with something. A good example for this is firewalls, right? Firewalls in general generate very simple, they're gateways. They allow things in if they're allowed in by a rule, or they block it if it's blocked by a rule, right? So they can do one of two things. Ideally, firewalls should log everything, because you'd want to know what's blocked, because you'd want to know if there's someone trying to do something particularly bad to your systems, or if someone inside is doing something bad out into the internet. That would be problematic. That would indicate you've been compromised. And you want to know what's being let in, because you want to know about things that are being passed. And if those systems happen to be, say, some guy out in Kamchatka running an attack bot, right? So you'd want to know that kind of thing. The problem is that the log volume here is massive. There are tons of things that happen across the firewall. Every single communication out to the internet or in from the internet happens on the firewall. So generally, the logs aren't actually collected, broadly speaking. The allow logs definitely aren't, because there's a ton of stuff that's being allowed from inside the business out. And the deny logs generally aren't either, because there's a ton of stuff just out on the internet. Every single piece of malware that's ever been built that's scanning the internet looking for old Windows XP machines. So there's constantly events happening on the outside of the firewall too. So very often, the logs actually aren't monitored, which is a problem, because it means that we're not actually bringing in the information we need for visibility in the first place. So essentially, right, you've got these logs that should ideally give you a whole bunch of information about what's going on in a certain place, i.e. the firewall. But because of the actual realities of managing and dealing with that data, you've got to actually get rid of a bunch of them, which reduces your visibility. This is an issue because if you wanted to keep some of the logs, which is what usually happens with EDRs and XDRs to reduce cost, you would need to identify which logs matter to the attacker, which presupposes what the attacker is already going to do. And you don't know what the attacker is going to do. That's why you've got the visibility tools. So this kind of creates this little bit of a circular logic here, where we're getting the visibility tools because we don't know what the attacker is going to do. And then we're only collecting certain logs because we need to, that are based on what we think the attacker is going to do, which we don't know, which is why we got visibility, which creates this bit of an issue, right? It's the issue with having these third-party bits of information is that we kind of have to presuppose stuff in a way that makes, no real sense in order to actually get the actual data that we want to find the bad guys, right? If we didn't have the problem, if we knew what they were going to do, we wouldn't need the visibility tools. And if we need the visibility tools, we don't know what they're going to do, so we need that data, which, creates the issue that we have with EDR, XDR stacks right now. So yeah, in a nutshell, organizations reduce the logs they collect to save on resources. This presupposes attack behavior. So they go, an organization will select which logs they think identifies what the attackers are doing, which means they're presupposing the attacker's exact actions. And if the attacker doesn't do those actions because they know it triggers the EDR, they won't be seen because you're not looking for the logs that actually do the actions they want. So basically, if you're using it in the way that most people use EDRs or XDRs, which is to tune out a whole bunch of logs and focus on very specific things, you're probably missing a lot that you're not realizing, simply because you're not collecting that data and you're not analyzing it from a perspective of, I want to know everything that's going on inside my organization to basically cover off the whole of, I don't know what my users are actually doing, and I don't know if my users are actually doing what they're supposed to be doing. So this is a big gap, which basically covers everything between someone breaking in the front door and someone actually running the malware, because in both those instances, you definitely know what's going on. That this middle bit where attackers can just kind of wander around between your systems and do whatever they like, so long as they're not doing the things that you specifically think they're going to do, or your engineers specifically think they're going to do. This is a big hole in visibility. Conveniently, we've sort of had this solution for it for some time, which is network detection and response. Network detection and response is actually first-party information, right? It's what actually happens on the network at any given time. Real actual communications that computers are actually doing, right? NDR only monitors stuff that's actually crossing the cables of your network, those little blue cables, or the Wi-Fi itself, right? And actually looks at what machines are actually doing to each other instead of reporting on what programs or software think they might need. So even if the actions themselves are invisible on logs, and even if you haven't captured those actions in specifically, they will still be visible on the NDR because they still have to perform those actions in order for them to happen, right? We don't have to worry about collecting logs that probably don't matter because we only need to just look at what's actually going on to identify, hey, this bad thing's now happening. NDR visibility is of a different quality than log visibility because it's actually what's happening, which means even though a computer may be tricked by an attacker to log things that it shouldn't, or not log things that it should, or an attacker can simply just bypass the logs altogether by not doing a thing that you're expecting them to do, the network detection system will actually see the actions going on and can report on it. So how does NDR actually work? Right, so NDR in a nutshell is a computer appliance that listens to traffic on your network. So the actual electronic communications going over cables and Wi-Fi inside your organization. And if it's in the cloud or in a virtual space, via the virtual network. So essentially what happens is this appliance is attached to, generally speaking, your physical network infrastructure or your virtual machine infrastructure or your cloud infrastructure, and it copies the actual network traffic as it passes through. You can sort of think about this as like an old school, like phone tap almost, where you've got a system that's literally sitting there listening to what's happening across the wire. Or you can think about it as like, say computers are sending mail to each other. You've got the post office clerk taking carbon copies of every single piece of mail that comes through and then sending those carbon copies off to the NDR, right? It's essentially invisible to attackers and listens to the actual communications that are going across and understands what those mean. So the NDR basically sits there, and listens to these communications, figures out what the computers are actually doing, and then based on that reports on anything, problematic, anything that really shouldn't be there, things that might be malicious. Ideally, what it'll do is it will tell the team or yourself or whoever it is when something is going on that shouldn't, and either offer recommendations for response or actively respond itself. So, ideally, basically this system will look for things that you're currently not seeing, identify them, tell you about them, allow you to do something about it, which broadly speaking comes down to anything from bad guys doing stuff to your systems administrator deciding that he doesn't want to follow policy. So NDR in general has had three generations essentially. And the reason for this is that environments have changed, what computers actually do have changed, how they communicate have changed, and the difficulty in collecting data has changed. So, there are a bunch of devices on your network, everything from Mac, Linux, Windows, whatever. They'll all work slightly differently. They'll all talk slightly differently. You'll basically those changes over time and how those things actually communicate have created the need for these new kinds of generations of tech. So it's essentially the generations you can sort of think about are increasingly sophisticated ideas about what normal looks like inside of a network, what things that should be worried about and things that aren't worried about actually are. And that's a surprisingly hard question, like at a pure math level. But that's essentially what pushes this thing up these generations. So generation 1, very simple, is what we called a signature-based system. The generation 1 systems basically would look for the malware in the network traffic. Like if you've got a worm in there, if everyone remembers like Conficker or Blaster or things like that, really old school Blaster, but still. The idea is that actually had to send certain communications to another machine for it to travel from one machine to another. So if you knew exactly what that looked like, you could just look through traffic for that. And if you saw it, you could go, that right there, that's a worm, that's bad, right? Very, very accurate when those signatures are good. However, you do need to get those signatures from somewhere. So generally buying a Gen 1 NDR also requires you having either a service or an engineer who actually identifies and writes those rules for you. So services will do it by having large amounts of threat intelligence they're building these rules from, and your own engineer will do it by understanding how your business works and then identifying how those programs that your business uses works and identifying cases that fall outside of usual behavior. Now, the problem with Generation 1, one of the major issues with Generation 1, is that it cannot read encrypted traffic. So unfortunately, thanks to Edward Snowden and the general discovery that the US government was watching everyone over Google, basically everything on the internet is now encrypted. And unfortunately, that's the same for your own internal networks. Most of the traffic that happens in your internal network is encrypted. Right now, the Zoom call you're on is talking over essentially encrypted traffic as well. So, if we were looking at this traffic using a Generation 1 system, it would be useless, even if we were doing malicious things and passing around files we shouldn't, right? It would not be able to see into that encrypted traffic. And so it has great issues with that. There are workarounds. They are not particularly secure and they're not particularly effective. It also can't determine a difference between good and bad uses of something, right? If a systems administrator does something with a tool that the tool happens to be malicious if used in the wrong way, the system will flag it. So if you've got automated systems that do CI/CD inside a development team, or you've got infrastructure as code, and it happens to run the systems administrator tools by itself, this will just flag it all the time, which is a problem because attackers will use those systems to broadcast and move around the network because they know that Generation 1 systems will get confused. This is a really, really serious problem given that the current modern state of cybersecurity is broadly living off the land attacks where bad guys are literally hands-on keyboard behind a laptop somewhere and are actually using the tools that your own systems administrators use to move around the network. So, it's really, really important to be able to tell the difference between a good usage of a thing that could potentially be bad and a bad usage of a thing that could potentially be bad. And Generation 1 systems just can't do that. So given that those two problems kind of became a major issue, we moved on to Generation 2. And Generation 2 is AI, right? machine learning, it predates the current AI wave that we've had because it's, it was from an earlier time than that. But it does broadly the same kind of thing. It's got a machine learning neural network system, generally speaking, that will learn from your network what things are normal and what things aren't. Normal in terms of these is, generally speaking, whatever any given machine is doing while it's learning. And that learning time can be quite long because it has to see every single normal thing that machine does. So, we're talking ideally, if you're really, really lucky, a couple of weeks. But in practice, 6 months, 18 months, really long periods of time. And the other problem is that any time what the machines you have do changes, say you move stuff to the cloud, say you add another business unit, say you add more staff even, someone brings a BYOD device from home. Anytime any of that happens, the system needs to relearn, which can again take months. So it's a very finicky piece of kit. It's immensely complicated and expensive to run because it needs specialized hardware, which you either have to buy or you have to pay for through the actual costs that you pay out to the cloud service, because they're going to have it somewhere. And if you're sending it out to the cloud service, you're sending bulk network data about your organization out to somewhere else, broadly speaking, outside the country. So if you're in government, you probably won't be able to touch any of these things anyway. And you also need specific engineers, like specific to the actual NDR Gen 2 system you're using, to understand and properly interpret / tune / fix any of the things that it learns that it shouldn't. Now, those can be quite expensive. And if you're not getting them direct, you either have to find a MSP or MSSP that'll actually be doing that, or you need to go directly to them in some cases and actually get people contracted to fly out to you and help you actually tune the thing, which can be, again, very expensive because those generally are PhD level, technicians. It needs retuning whenever changes occur. It needs specialized hardware, which generally means graphics cards. And if any of you game, I know I do, graphics cards have been very expensive for the last few years, so prices for those systems have been going up. And sneaky and stealthy attackers can abuse the fact that the system learns anything that happens or happens over time as normal to sneakily produce traffic that looks like what they're going to be doing. Like if they want to convince the NDR that the AD just sends, credential data, or the file server or the database just sends customer data, they have to do just very, very little requests that look something like it, just slowly increasing over time, and the NDR will slowly learn that that's normal. So when they push your entire customer database out to somewhere in China, they're like, well, the NDR is like, well, I mean, that's been happening since, whenever, it's been happening for ages, and no one really bothered me about it because it wasn't, much. There wasn't much of it, and no one was really throwing any, trying to tell me to do anything different because, you'd need something specialized or someone specialized looking at it 24/7 to do that. So, it looks normal to me. It'll be fine. This is because attackers expect AI-based NDR, EDR, or XDR to be watching, specifically EDR and XDR, which work very broadly along this idea of, whatever's going on and keeps going on and isn't interrupted by someone might actually be normal. And they know that that's what they're trying to defeat, so they've got methods of getting around that, which generally just means them taking more time. All right, cool. So that brings us to Generation 3, which, based on the problem that Gen 2 NDR could be tricked and also was ludicrously expensive, Generation 3 basically goes, well, how can we get the same kind of visibility, but without all of the downsides of using AI in this environment, right? How do we just know what normal is? And the answer is that we use this really, really cool cutting-edge set of mathematical techniques that provide a universal model of how networks work. This means that normal isn't whatever any given computer is doing, but how what that computer is doing relates to other computers that actually do the same kind of thing. So we're looking at computers in their behavior with regards to the whole of what your organization's doing. And if someone's doing something that, might be normal under other circumstances, but in a way that doesn't make any sense, that's very, very obvious at a Generation 3 level, right? Now, because it's using math that's well understood, as opposed to having to learn everything to begin with, it's way, way faster to train and just has to do some statistic samples. Doesn't need specialty compute, and does kind of require specialized Gen 3 people. So positives, it's way, way more affordable, it's way, way more effective and accurate. But the downside is that you end up with this issue that you need to have specialized Gen 3 people, not just NDR people, because Gen 3 works differently to Gen 2, works differently to Gen 1. Generally speaking, NDR people will be working whether they're a Gen 1 or a Gen 2 if they're lucky. There's not particularly many Gen 3 people out there. That said, if you can get with a group like Morfit, who, has us at least, we've got the capability to do that sort of analysis work for you. So, you can use MSPs that use Gen 3 systems to get that technical capability, as a service. So yeah, generally speaking, the broad things to note with NDR are that you're going to need someone that knows how to use it. And they need to know how to use it well. Same reason that you need someone that's an XDR specialist or an EDR specialist to drive your XDR or EDR, right? You want the right analysts for the right tools. You'll want to know how to tune it to find what you want to find, which realistically requires putting it in the right place on the network, which I'll talk about next, and interpreting what it does find and identifying what that means in the broader context of the rest of the information getting out of your system. And it can be quite tricky to find a good NDR. There are a lot of systems out there that are attached to XDRs that are basically Gen 1 or Gen 1 hybrid systems that kind of do some Gen 1 stuff and then use the AI of the XDR to help out. Actually identifying an NDR that does like a Gen 2 or a Gen 3, and Gen 2s are generally fairly easy. You find the most expensive NDR in the room. But finding a good Gen 3 can be quite tricky. And yeah, identifying what the difference between generations is quite tricky as well. So you'll want to ask things like, what kind of, how does this actually work, right? Does it use AI? How does it use the AI? Is it used to train the system? You'll want to ask those sorts of questions while you're choosing an NDR or asking someone, hearing about an NDR from someone, so you can actually figure out which generation it is, which will help you identify whether or not it's something you want to use, given what you're trying to achieve. All right, quickly thing on deploying NDR. So basics of deploying NDR, you want to connect it to your network infrastructure. So you connect the NDR to something that collects network data. Usually this is a span or port mirror, which is a function of layer 3 networking equipment. So if you've got a Cisco switch, generally you can just do it. If you've got Fortinet, same sort of deal. If you've got something like a random, IINet or, Telstra gateway because you're a small business, yeah, you might need new networking equipment. Alternatively, you can use a tap, which is basically a particular appliance you put on. Basically, you connect two sides of a cable into, and it copies anything that crosses that cable, those two cables. So you can basically use it like an actual phone line tap almost, and that will do the same kind of thing, but for that cable. And if you're in a virtual environment, you'll be using a promiscuous network, which is a specific kind of network inside a private cloud that allows you to copy data from certain sets of machines, or a VTAP or similar out in the public cloud, which is essentially the same thing, but with a fancier name for the public cloud. Now, some NDRs can use NetFlow data, which is a specific Cisco kind of data that can be produced by switches. Some systems can, some systems can't, and there are some considerations here. Generally speaking, NetFlows produce less data, so it's easier to collect and easier to move around the network, but that data is of less definition, right? There's less information in that data. It's reducing the conversations down to a conversation occurred as opposed to the contents of the conversation. So if you're trying to get higher visibility, certain systems that require that higher visibility will be using raw packet data. Some systems will be able to infer a lot from net flows. Generally, the systems that are using net flows are going to tell you that they're going to want an XDR of some description as well, so they can get extra context. It really just depends on what sort of systems you're looking at and what your networking architecture can actually produce. So ask your networking engineers or your systems administrators and see what they produce, and then you can basically go, right, well, I have these data sets that are available to me. What data sets can the NDR that I'm looking at, or NDRs that I'm looking at, actually consume? And of course, if you're looking for really high resolution stuff, you'll want to aim for things that are more raw packets. And if you're trying to get data from very, very varied locations over a great distance, it might be better to use NetFlows depending on the solution that you're looking at. Generally speaking, the better the data is, the better the results are. So if you can get network packets, that's the best solution. But if it makes more sense for you to use NetFlows, you can more easily route them around your network. Now, strategic positioning. This has to do with how to best tune your NDR, essentially. You'll want to think about more than just slamming an NDR into the core switch that you've got, right? So generally, your organization will have a switch that's just outside of the gateway or the firewall, essentially, where, or even just back from the DMZ, which will have the sort of core location where basically all of the network connects to. Usually it's like a big Cisco or something, or a Fortinet or something like that, right? Unfortunately, networks aren't usually just a big hub and spoke. So slapping an NDR into your core switch will leave a lot of things that aren't where the core switch is unheard. Things further away, if there's smaller switches or Wi-Fi networks further away from the core switch, those won't necessarily come up to the core switch to talk. I mean, if two machines on the Wi-Fi want to talk to each other, that's never going to go across the core switch. Now, that might not matter because you're not trying to defend what's on people's laptops. But if you've got servers on Wi-Fi, or you've got servers that could be, maliciously attacked, that doesn't require cable like communications to go through physical cables or cabling that goes through that core switch, then you may need to have multiple places to put your NDR, right? You basically want to think about it from the perspective of bad guys have to move across the cables, right? They can't just magic their way through stuff. They've got to actually follow your networking infrastructure. So if you have a map of the networking infrastructure and know where in that infrastructure the things that you actually want to protect are, you can put the NDR where those things are and get best quality results, because it'll be able to go, well, if a bad guy has to get to my customer database to actually do me damage, then if I've got NDR next to the customer database, regardless of where the bad guy comes from, they have to go past the NDR to get access to this, which reduces your costs because you have less of an NDR footprint, and you've got less devices scattered around your network in terms of like monitoring systems, reduces the amount of logs that you have to deal with and analysis work you have to deal with because there's less stuff to look at. Also, gives you higher, impact because you have only logs that have to do with systems that matter to you. So yeah, thinking a little bit about where to put these things, really, really effective, both in cost and effectiveness, and really in workload to your team. So it's important to chat with the people that actually know what your network looks like, and then talk with your security team on the idea of, okay, if you were bad guys, what would you be targeting? How would you get in? And then based on those answers, figure out where the choke points are, and those places are where you want to put the NDR. Right, quick thing on the cloud. NDR is not for cloud apps. So if you've got O365 or Salesforce or whatever, where there's a bunch of them, those are actually applications that just happen to run on the cloud. They produce logs. You'll want an XDR or a SIEM for that. They'll collect those logs and analyze them. They don't actually use network traffic for that. Cloud servers, so if you're in AWS, EC2, for example, that's the sort of space that you're looking for networks that exist in the cloud, like a virtual data center. Those are the sorts of things you want to watch. If there's virtual servers you got out there that are running virtual applications, those are what you want to watch. If you're looking at just like cloud applications, you want an XDR. Public cloud generally has a VTAP or something similar, which allows you to select a number of machines and collect traffic from them and send them to another virtual machine. Azure can be really tricky. There are only a few NDR companies that can support Azure because Azure at the moment doesn't have VTAP. And so you have to use agents to actually collect data. So just be aware if you are heavily deployed in Azure, you'll want to talk to the NDR companies that you're looking at and ask them, hey, how do you actually approach Azure? Because some of them will just be like, we don't. In fact, quite a few of them will just be like, we don't. And that's fine. There are ways around it, but it does mean that it reduces the amount of NDR solutions you can look at. But that's pretty much the only issue. Everything else works with VTAPs, and everything else can be like, if you've got Oracle Cloud, Google Cloud, AWS, they all work with that. So, really nice and simple. You select the machines you want to select, and that copies the data over to another virtual machine, which generally is the NDR virtual appliance. Private cloud, same kind of thing. It's fairly easy. If you've got vSphere, for example, or a Hyper-V, you can use a promiscuous network to collect network traffic from a certain segment of the virtual network and copy it across to the virtual appliance that's doing the actual NDR analysis. But this actually can have some resource impacts on the NDR and not on the NDR, on the virtual machine host, so your actual virtual cloud infrastructure itself. And that's because in a virtual environment, it's just running on someone else's computer. And in this case, it's running on your computer, ideally, if it's a private cloud that you've got internally. And that machine actually does all of the network stuff, right? It's basically pretending to be a whole bunch of networks. It's just copying data across from machine to machine and saying, yeah, these are network cables. So if you turn around and say, hey, I'd like you to get a copy of all of the network data on this network segment and give it to this virtual machine that's then going to do analysis. That machine actually has to do extra work to copy all of that network data over to this other guy. Now, generally, if you've got some margins in terms of like, CPU or memory resources to actually cover off, if there's like an increase in usage across your virtual cloud, that's not an issue, right? It's not enough traffic for your virtual systems to get overloaded or something. But it can be important if you've got, say, time critical applications or things that are really important and sensitive to resource, competition. Again, talk to your network, talk to your virtual machine administrators, your actual cloud administrators, the engineers that are working on that stuff to get an idea on what they think. If they can't deploy it on the actual virtual machines themselves or the virtual environment themselves, that still connects via a physical cable to your real actual infrastructure. So you can just listen there. Private clouds that you don't own, that one's a bit more of a tricky situation because they are sharing their virtual resources between multiple companies. So it may be quite tricky for them to actually collect data from just, your organization. So you'll want to just chat with them. They'll be able to tell you what their rules on NDR and how their NDR policies work. And if they don't, now's a really good time for them to figure it out because they should be being asked that question reasonably often. So yeah, cloud works is long story short. It just depends on what sort of systems you're using, how you're using them, and what kind of restrictions you have in terms of resource usage. So finally, what can you actually get from NDR that matters and why would you actually want it? Well, firewalls, for example, as we sort of said earlier on, are just simple things that, they either let things in based on rules or they let things back out based on rules, right? They allow things or deny things based on those rules. Those rules are set and realistically should be being audited pretty often. Now, unfortunately, I know quite a few businesses that have never audited their firewall rules. And so they have things that are rules that were set for really, really early instances of what they were doing in business that have long since changed, but still valid. So things are being let in that they probably shouldn't be letting in. But that means that there are very often things that the firewall is doing that you don't know about. And this is compounded by that problem that I was talking about earlier, where logs from the firewall are very rarely kept in verbatim, which means that you don't actually know what it's letting in and what it isn't letting in, which means you've got no visibility at sort of like the day-to-day of what the actual rules are doing. So that can be a bit of a problem if the attacker is actually actioning stuff across protocols that the firewall allows. For example, from experience, we had an organization that was using FTP very early on, and then they stopped. But they had a Linux server that was still running an FTP server. So the internal FTP was allowed, but external was supposed to not be. However, they had not actually changed the rules at the firewall level. So the firewall was still allowing people to access the FTP server. So when we deployed, we very quickly, and by very quickly, I mean in the first day, were able to identify that it was a large amount of traffic being sent in and out by someone in China. This organization did no business with anyone outside of Australia, and they shouldn't be having FTP communications from anyone but their own staff. So this was a significant problem. But because they didn't have that sort of visibility over the logs from the firewall, and because they hadn't really looked at their firewall rules too hard since really setting the thing up, they could not see that this action was happening because according to everything else on this in their environment, this was an expected behavior. The firewall was allowed to pass FTP traffic through. It was expected. I mean, it shouldn't have been there, but that was expected by the firewall. And the device that was handling FTP, it's Linux. It doesn't have an endpoint defender on it. It's just sitting there and going, yep, I'm just doing FTP sessions. So there's no visibility on that either. So there's no EDR on it. And the firewall thinks it's totally legitimate. So the whole network environment, as far as the tools are concerned, totally legitimate. The only thing that saw it was the NDR. Which allows them obviously to fix it. And that's what they did. Now, this can be a lot worse because broadly speaking, nearly everything over the internet is HTTPS, so encrypted HTTP traffic. I know most of the time when I'm doing these kinds of calls, I'm pretty sure Zoom does, this communication is either HTTPS or it's something called QUIC, which is HTTPS but faster. That's encrypted, fully encrypted. Gen 1 NDR can't touch it. And also most other systems can't touch it because it's invisible or it doesn't make any sense to anything that doesn't have the certificates. So the firewall kind of has to allow HTTPS because everything uses HTTPS. Your websites, your calls, your file services, your web apps, everything. So this is a very common attack vector because you can just disappear as a bad guy into the noise of HTTPS and no one can really tell that your communication shouldn't be there. However, to Gen 2 and Gen 3 NDR systems, specifically Gen 3 and to Gen 2 when they're used properly, you can tell the difference. Hey, HTTPS, this stuff looks like it's normal behavior. This one is not. This one's talking to China. These ones are generally talking to, wherever the heck you do business. Or this one's talking to Kamchatka was another good one. And everyone else is talking out to, somewhere else that we do business. Or it's talking to Facebook or Microsoft or whatever, right? So you can tell that there's behavioral differences between the different types of communication. And even without knowing what's inside of it, you can go, actually, I need to go to that machine now and figure out what it's doing and who it's talking to. So very, very common attack vector. NDR provides you visibility into when that's not doing what it's supposed to. Next up, things that your EDR can't see. Now, EDRs are really cool. Generally, they work very well. Unfortunately, attackers are very, very smart, and they have figured out that there are things that EDR can't see. For example, things that never touch the disk, right? EDR, at the end of the day, has a heritage in antivirus systems, right? And broadly speaking, the things that it's looking for are either logs or they're artifacts. So they're things that actually exist either on a disk somewhere or on some sort of medium. Living off the land attacks are bad enough because they use applications that are already known and allowed to be used in your environment. They're things that your own users use. They're just being used for malicious ends. But worse than that, attackers can actually put entire tools in memory, so they never touch the disk. And when they do this, it's basically invisible to EDR under most circumstances. It's even worse still when they hide these tools inside other processes. For example, Chrome. Great browser. We all love it. Unfortunately, it's ludicrously complex. And this is one of the reasons why it uses so much of your computer's memory, right? These things are nearly operating systems in and of themselves, the current modern browsers, which means they can do a lot of things. So if an attacker can compromise Chrome or build a compromised version of Chrome, as is the case with some particularly famous banking malware, that looks like something that's completely normal to EDR. And if that is entirely in memory, say if they've compromised Chrome on your browser, and then the actual malicious code is running inside the browser itself, that's essentially invisible to EDR. And so if the attacker can then move or pivot to something else that's also in memory from that point, as they tend to do, that's also invisible to EDR. And so your EDR can be working perfectly normally, it's just unable to actually see the attacker, which, is a problem. Thankfully, attackers still need to move across the network. They need to get from computer to computer if they're going to do any real damage. And they've got to get to your laptop in the first place, which means they have to move across the network. They're not physically in your data center, so they have to move across the network. They have to move those tools, even though the tools are invisible to the EDR over the network, which means the tools aren't invisible to the NDR, which is looking at that network. Again, first party versus third party. The third-party intelligence from the logs won't show anything because Chrome is the bad guy at this point. It's been compromised. It is now the spy inside your organization. It's the problem. But the NDR is looking at first-party stuff. What is Chrome actually doing? And that means we can now go, okay, well, now it's actually doing stuff that it shouldn't be. Or this random application that's on this machine that doesn't seem to have a file associated with it is doing something, and it's doing something bad, right? We can actually see those behaviors from the network, and we can see them operate and communicate, which means even if it's invisible to everything else, the actions they perform, the actions the attackers perform are visible from the network layer, and that's why the NDR is such an important piece of the puzzle. You also get metrics you wouldn't otherwise have, which can be wildly important, especially if there's a wall between the security team and the systems administration team. Think about it. IT's job is to make things work, right? If things don't work, people can't do their jobs. So IT's job is to make things work. And security's job is to make things selectively not work, right? We're always at odds, right? It's just the nature of the business. We need to make sure only the right people can do things. And IT's job is to make sure people can do things. It overlaps and is a problem. So, very often I find organizations where the systems administrators and the DevOps team, especially the DevOps team, is doing things that they don't want the security team to see because it gets in the way of them doing their jobs, because they don't want to have to go through all the loops or all the hoops to actually get their stuff done, right? They just want to build stuff. They just want to make things happen, right? Because it's useful. It makes it does what they're supposed to do. It helps them do their job. So having visibility on what they're doing beyond just what they tell you they're doing is really, really useful in identifying if policy is being followed by privileged users, and then identifying what to do about people that aren't following policy as privileged users. We've been involved in a few of those, just internally. We've had people that we've seen clients that are bypassing policy that have privileges, and then been able to report that back to security teams, management, etc. on, hey, this is the risk that this person is creating. So if you don't currently have that visibility, you probably don't, NDR is really, really good for that sort of metric. It can also tell you, broadly speaking, what people are doing inside your organization, what they usually talk to, what they do during the day, what kind of activities they perform, how they do their work, what kind of websites they use, if there's any resources that are being used strangely or unusually, right? This tells you things like how to best train people. Are they doing stuff that bypasses policy? Do you need to tell them, well, we need to be more secure in how we act, right? What kind of things are they trying to do that bypasses your security policy to get their jobs done, right? So you can sort of better tailor your strategy with engaging with the users. And also it gives your team, your actual cybersecurity team, the idea of what normal looks like inside the organization beyond what is just reported by systems. The human brain is the best anomaly detection system that we know of. It's significantly more effective than AI by like a long margin. If your team can look at a screen and go, yes, that's what normal looks like, and then look at the same screen and go, there's something wrong there, that is super useful, because that off feeling in their gut, that's a really, really useful starting point to identify when something's gone wrong, if you can get that information. And NDR provides that information because it's providing first-party information on the behavior and actions inside your network. So really, really powerful for that sort of, SOC, broad cybersecurity idea of like, what is my home turf advantage? What do people actually do? And honestly, it's the coolest thing as far as I'm concerned, being able to see what people actually do and go, yeah, that totally looks like a normal business. But that's basically it. In general, that's NDR and XDR and EDR and how they sort of interrelate, why NDR is important, and also, why you probably need to be thinking about looking into figuring out which NDR works for you and then grabbing one. Now, obviously, I'm a bit partial in this one because we're the Australian Gen 3 NDR, Hyprfire here. We're pretty gosh darn cutting edge and run on things that are basically anything. And we actually provide a wraparound service around what we do so that you don't actually need to go and find specialized Gen 3 NDR people. We actually have an analyst team that does the analysis work and simplifies everything right down to, these are the things that your team needs to worry about today, if anything, right? Generally, it's a really short little report. It's just like, hey, everything's fine. But on the days that it's not, that's when it's important, because it's that sort of visibility of things that shouldn't be happening, things that people are doing, things that they probably shouldn't be doing, and of course, malware and incident response work that we really shine in. That sort of finding the stuff that you guys won't, or your teams won't be able to see with those sorts of third-party information from the logging systems they've already got, and without you having to commit an FTE to the work. We obviously work with Morfit. We're having a great time. Chat with basically our guys or Morfit's guys, and we can get you set up. We can deploy tomorrow and get you results within the day. So chat with us to get some NDR capability into your cyber stack and close the hole that's currently there.
Thanks, Stefan. Phenomenal presentation. I think we've probably got time for maybe 1 or 2 questions before we hit the hour. If anybody has any questions, feel free to submit them through the Q&A and we can read them out for you. Or if you prefer to talk, I can definitely unmute you if you wanted to raise your hand. While we wait for questions, I did have one, candid question from my side, Stefan, to get the ball rolling. I was wondering if you might be able to give us a example of potentially a real world or specific threat or attack vector that potentially an NDR solution like Hyprfire might pick up that would typically be missed by EDR or XDR.
Yeah, okay. A real world solution a real world capability that an attacker would use that EDR or XDR would not be able to pick up. So this really depends on what sort of the stack of an organization looks like, because, if someone's set up like the most bulletproof, insane sort of thing, so they're a Fortune 500, they can do a lot of things. But I guess under most circumstances, people sort of have an EDR or an XDR and they've sort of just plopped it in there. We're sort of just working from, what's been set up really. And so, you know, you can get things like, an example we've got is, if you remember a couple of years ago, there was a Log4j, right? Big issue. The only way you could really pick up Log4j is if you were looking specifically for a communication that looked like the Log4j inject script. So one of the things that's really neat about that is those communications have to travel across the network just verbatim unencrypted. So if you're watching for those across the network, you can go, oh, hang on, there's a thing. There's Log4j, right? So the trick with Log4j is that if someone manages to hit a machine with Log4j, generally speaking, because Log4j actually targets the logging system itself, it can actually prevent it from producing a log that actually says that this happened, which was the case with VMware Horizon. And so, you know, we've helped out with a couple of situations where NDR in general is a great solution for these sorts of things, just broadly speaking, where one of these communications would come in and then the device itself would perform the Log4j second stage, where it actually reaches out to a malicious server to try and run something, which is where the malware gets in. And of course, we don't only just see, you know, while the XDR EDR is not getting those logs, and of course, VMware Horizon's running atop, you know, a virtual machine infrastructure on Linux, which, you know, if you're running Windows Defender, there's no EDR for that. And very broadly speaking, there are only a few Linux-based EDR systems. But say you don't have that, you know, that's not going to produce a log. That information is not going to get picked up. Suddenly, the actual VMware Horizon application is what's been compromised. So if the attacker's done it right, they can then use that application as cover to then load their malware into memory and proceed to then move to the next stage. So not only do we see the actual call out to the network that's like, hey, I want to download totally not malicious application, which, you know, good indicator that they've been compromised. We also see the behavioral changes afterwards, because of course they've affected the application itself, which changes how it behaves, which means that, hey, something's just happened to the VMware Horizon right after this weird message went out. And we can also see what they're doing next. For example, one example of this was people then moving from a authentication server further into a network using reconnaissance methods involving DNS scraping and LDAP enumeration, which is really, really great ways of figuring out what's what inside the network without doing too much things awry, because most machines inside the Windows network will be using one of those two mechanisms to figure out where the file server is, where the AD is, where the DNS is. They'll be asking around for that. So something else asking around for that, oh, that's not particularly untoward, except in the way that it's doing it, right? You don't expect the, you know, authentication server that doesn't actually run Windows to be, you know, performing Windows-like actions. So, you know, again, not only do we see the actual attack, we then see the changes in behavior, both of the application that's been affected or compromised, and then the next stage the attackers are using to pivot into the network. So, you know, EDR and XDR, very unlikely to pick up something that doesn't have actual logs attached. Again, maybe you catch it at the firewall, but you're probably not holding logs from the firewall. So the only way you're going to be able to know is by the fact that the system's now been compromised. So another good example there is, systems administrator having ownership of his machine, does whatever he likes. He's got full local admin authority. Organization is a Citrix. Right? You'd expect them to use the Citrix, and this is how their policy works. People want to remote in when they're working from home. They go through the Citrix. System administrator doesn't use the Citrix, goes straight to his laptop. That's a bit of an issue, right? Again, firewall's allowed for it because he's allowed it past the firewall. The device isn't reporting on it because he controls the device. So there's no logs for that because he's explicitly denied them because he knows what he's doing he's not supposed to be doing. But the NDR, of course, is watching the actual behavior. So, okay, now I can actually see what he's doing and can tell someone a bit above him, hey, did you know the systems administrator has built himself a backdoor? So those kind of examples are like really simple ones. So
thanks, Stefan. So we've got one more question here from an anonymous attendee. So people are working from home these days, and most services they consume are SaaS-based. How much user to data visibility value can an NDR solution provide in such scenarios?
So yeah, if you're working from home and using just SaaS, the only things you're going to be able, like, if you can, having an agent-based system that's sitting on those laptops may give you better information on what's going on in your users or your, you know, your users on home networks, which can be important because those networks are obviously not up to security standard on your organization. And if an attacker can get to a laptop say at a cafe, and then by the time they go, oh, heck, at home. I know, for example, the LastPass breach was specifically because of the usage of a work from home environment. And because the user at home was running a Plex server, which was compromised, they were able to then pivot into his laptop. So that's how they got in, right? They used the fact that the home network was not very secure. Because again, our home networks generally aren't. I mean, I would say that me and my guys generally have a far more secure network than most people in terms of at home, because we've all got like physical firewalls and stuff, but most people don't have that. So generally speaking, you'll want to have some visibility on it. So an agent-based NDR will give you an idea of the behaviors associated with the machine inside their networks. If you're using something like a SASE or remote from home sort of solution, because you've got applications running in a cloud data center, for example, if you're running custom applications, that's obviously a place you can do NDR visibility. But yeah, in general, you'll want to know what the behaviors are that the actual machine's using with regards to your cloud appliances, because that'll give you an idea of whether or not someone is now using their laptop as a pivot point to collect data from those applications. Broadly speaking, though, NDR shines when you have actual networks. And yeah, there are quite a few people working from home. And yeah, with smaller businesses, maybe that's, a bit more of that sort of agent-based stuff. But there are a lot of applications that you can't deploy. You can't just run out of SaaS stuff in the cloud. You've got to run them actually on servers. And sometimes, organizations have bespoke software because, they've had it built specifically for their use cases. And even more specifically, if you've got OT environments, which are broadly insecured, those physically have to exist. So you actually do need to monitor them. So I know that critical infrastructure organizations desperately need this sort of thing because there are things that they actually have that they can't move, right? If you're running a cloud, for example, that cloud has to physically exist somewhere. You need visibility over it. So yeah, while, it depends, again, with all cybersecurity tools, it really depends on what sort of situation you're in. And there are benefits to having all kinds of visibility in all situations. It just depends on which parts of visibility you implement first, right? So if you're all work from home and all SaaS, probably go with your XDR first because you'll want to get visibility over that SaaS, right? But if you are, running an organization that has like tons and tons of building management systems running over like, BACnet or Modbus or one of these OT things, well, those are physically there and those systems are broadly easy to attack. So you want visibility over that. So you'll want to go for a networking-based solution pretty early on. But, classic cybersecurity stuff.
Yep, the right tool for, I guess, the right problem, right?
Yeah.
Cool. Thanks, Stefan. I think we'll wrap up there, guys. Thank you, everyone, for joining. We will be following up with a copy of Stefan's slides as well as a recording, but do feel free to reach out if you had any questions in the meantime to either the Hyprfire team or the Morfit team. Cool. And we'll leave it there. Thanks, guys.
Everyone.
Excellent. Thanks all.
Bye.